Okay, so this is another example of Whirlpool maps. I'm calling this the orthocenter or the X4 Whirlpool map. And what we're going to do is we're going to start from a triangle ABC, ABC, and we're going to elect a starting point, P0, represented here by the 0 star, so I can drag this guy around, right? And what I'm going to do is I'm going to do consecutive applications of the orthocenter of these triangles that I can compute. Let's go ahead and illustrate the first triangle. So I'm going to start with side AB, and I'm going to go ahead and construct a triangle that contains that 0 point as its apex, right? So it's this brown triangle here. And then I can compute its x4. Its x4 is going to be shown here by this number 1. Okay, so number 1 right here, or P1, is the x4 or the orthocenter of AB0. Now you can see here that it lies on the line that is perpendicular to side AB, as expected, because an orthocenter is a midpoint of three perpendiculars dropped onto the sides of the triangle. So the first application of this map is going to take me from 0 to 1 in a direction perpendicular to AB. Let's look at the second application. I'm going to construct a triangle with the next side on the counterclockwise order, in this case BC, and taking the last computed orthocenter as a apex. Okay, so it's this triangle here. Now this triangle, you can see, is an obtuse triangle, so its orthocenter is going to lie in its exterior. Now, as it turns out, the orthocenter of this triangle lies right here, where you see number 2 indicated. Now we can verify that the line connecting 1 to 2 is perpendicular to the base of this triangle BC. So you go from 0 to 1 in the first iteration, and then from 1 to 2 in the second. Let's do the third iteration just for illustration purposes. So now my next side on the iteration is side CA, and the apex is 2. So let's go ahead and connect. Form this triangle here in my iteration. So I have this triangle formed by side AC and the last x4 computed. And again, this is a pretty obtuse triangle, so its orthocenter is going to lie, did I do this right? Yes, it's going to lie over here on number 3. So this is the orthocenter of that triangle. And it's the 2-3 direction is perpendicular to the base AC. Okay. And then you can continue to do this application. Okay. And what you find out with the X4 Whirlpool map is that within 6 applications of the map, irrespective of the triangle ABC and your starting location, you close the map. So after 6 applications of the X4 Whirlpool map, 1, 2, 3, 4, 5, on the 6th application, return to point 0. And that, you get this hexagon, right? You get this hexagon, the red hexagon, asymmetric. Each one of its sides is perpendicular to the base of the iteration triangle. Its area is variable, so it's, as I move 0 here, the area ratio between ABC and itself is variable. And it also depends on the shape of ABC. So if I move my triangle around, okay, I get a different polygon. Let's take a look at this one over here. And let's do this kind of thing. Okay, I'm moving 0 around. Now if I go outside of the triangle, my polygon becomes big, like so, right? But it's still a hexagon, denoting the closeness or closure of this iteration that is being called X4 Whirlpool map in 6 iterations. Okay? All right, now there's one more property that is quite beautiful here, which is, okay, let's go back to that scene where 0 is approximately here. Oh, by the way, before I go into that property, let's look at what happens when you get an equilateral triangle. Anything interesting here? Let's look at an equilateral. Are there any patterns here? Maybe not. Nothing really that interesting. Okay, let's go back to a triangle that is not equilateral. Scalene. Okay, let's put this over here. Now, I'm also showing X4 of ABC, right? It's being represented here. but that's not germane to what I'm about to discuss here. Okay, so let's leave it on this sort of default position here, for lack of a better term, or generic position, general position. Now, very interestingly, if you think of the conic that passes through the original point 0, or the starting point 0, the three vertices of ABC, and x4 of ABC. So this is a rectangular circumconic. It's a rectangular circumhyperbola because it goes through the x4 of ABC. So if you think of this rectangular circumhyperbola, what you find is that every application of the map swaps you from a point 0 on this hyperbola to a new point 1 on this hyperbola, and then to a new point 2, and so forth and so on. So you stay within this hyperbola. Now, of course, the hyperbola depends on the inputs, which are the vertices ABC. That gives you an x4 of ABC and the starting location 0, right? But provided that you just maintain, sorry, you maintain everything constant, you get this closure upon the hyperbola itself. Now, because this is a rectangular hyperbola, why is it rectangular hyperbola? Because it passes through x4. We also know that a corollary is that the center of this hyperbola is going to lie on the 9-point circle of ABC. Okay, so that's an additional property of this map. Let's just take another position here, for example this one, and you can see that the 6 points that constitute the cycle, they fall upon that rectangular hyperbola, defined by 5 points, P0, the x4 of ABC, and the 3 vertices ABC. Now, one thing that is not obvious here, but it is a case, is that if you reverse the map, so instead of starting with the sequence A, B, B, C, C, A, you do it in clockwise fashion. So you do B, A, C, C, B, etc. You get the exact same final polygon. So the polygon is independent of direction, this hexagon, right? We haven't studied this much, but you can tell here that this hexagon has opposite sides that are parallel to one another. For example, 4, 5 is parallel to 2, 1, right? And 3, 4 is parallel to 0, 1. Why is that? It's because there are 6 sides for this hexagon, and each one of the sides is going to be perpendicular to one of the base sides of the iteration triangles, according to the Whirlpool map. And then, of course, after you've gone through one triad, A, B, B, C, C, A, then the next one, the fourth one, is going to have the exact same direction. So let's say if we take AB, we're going to see that 0, 1 is perpendicular to AB, and then 3, 4 is also perpendicular to AB, right? So that's about it for what I wanted to show you guys with respect to this so-called X4 Whirlpool map. And I'll see you on the next video.